Have you ever wondered how exactly your body breaks down the food you eat into usable energy? Enzymes, a special kind of protein, play an important role in this process. Let's take a look at one specific example. When we covered proteins, we introduced amylase. All enzymes, including amylase, have a specific substrate that they work upon. A substrate is just a chemical that is changed from one form to another, and the enzyme's job is to speed up this chemical reaction occurring. The substrate for amylase is starch, a compound found in plants. Amylase's job is to break down starch into smaller units called maltose, which are easier for our body to use as energy. Let's go ahead and take a closer look at how exactly this all works. Each enzyme has a unique space called an active site. The active site is critically important because it's where the substrate binds to the enzyme. As you can see, when the substrate binds, the enzyme changes its shape very slightly to fit the substrate. This is called the induced fit hypothesis. The chemical interactions that occur as part of this induced fit cause chemical changes in the substrate to speed up. This is the whole point of the enzyme, to speed up a chemical reaction. After binding to the enzyme, the substrate will change form and then be released. The enzyme can then be recycled at the end of the reaction. Let's take a quick look back at what happened there. We start with a substrate, which is some kind of chemical, in this instance starch, and the enzyme catalyzes the breakdown of starch to maltose, a smaller, simpler sugar. This means the enzyme speeds up this chemical reaction. At the end, the product, maltose, is produced, and the enzyme is recycled so it can be used again. So before we move on, let's recap. The purpose of each enzyme is to speed up a specific chemical reaction that happens in an organism. The substrate that the enzyme acts upon binds to the active site. The enzyme then changes shape slightly. This is called the induced fit hypothesis. And then the product is released and the enzyme is recycled. Let's put this all into context. In real life, the reaction you're seeing can be catalyzed or sped up by amylase 100 times faster than this clip. Without amylase, this reaction wouldn't even happen at all. If we speed this up even more, the speed is still 50 times slower than real life. As you can see, enzymes are really remarkable molecules and are incredibly important to ensuring our metabolism functions properly. So this is how our body breaks down the energy in plants to a usable form. Without enzymes, the starch that we eat would just sit around in our body doing nothing. In the next video, we are going to examine how exactly amylase breaks down starch and what could go wrong with this process.